Can I be at again?
So the next talk would now be Werner Arber. Professor Arber is a Nobel Laureate and has made 5 years ago on innovation a beautiful slide, and I asked him, could you speak on the process to show how science-based innovations must respect the laws of nature, as you have shown that some years ago. And I would be very grateful if you today tell us about this again, because it's very important for all of us.
Well, thank you very much. I'm glad to reflect with you on a scheme which I carry with me since a number of years. Here it is. That's my only projection, so there will be just comments on. You see, innovation is down here. Scientific knowledge comes from research, basic research. And there are ways then to get down to innovation. And innovation is in fact shaping of the future, shaping of my life's future, shaping of the future of the whole civilization, shaping of the future of biodiversity, and so on and so forth. So there is some responsibility in that. So let's go through to acquire basic knowledge on how nature functions depends very much on the methodology which you have. So the political world usually considers only to stimulate acquiring knowledge and going down to applications. Rather seldom they consider the importance of introducing new strategies of research. And I do consider nanotechnology as a new, nanoscience as a new strategy to investigate life altogether. And so this scheme, of course, I have not done it for nanosciences, but in general, this is, to my mind, valid for any kind of scientific investigations, how it works. But let's talk on investigating life processes. For a long time, this was done just by observation, with our eyes, with our other senses, and so on, and the intelligence reflecting. And I do see in the Old Testament, in Genesis, for example, an example of a very early scientific publication on which people reflected, looked at them, they felt, how did it come to me and to what is my environment? And they must have said, well, I cannot have been the first, and then only the land came in and so on. Rather, it starts with having the land on the first day, then, in fact, land and water, and then land and water was separated, the oceans and flat land. They didn't realize that we are on a global planet, but they felt everything is flat. That's all right, that's from observation, where they were. And then light came in only. Astrophysically, this, of course, is not correct, but we are aware that they had no astronomers and astrophysicists at that time, several thousands of years back, when these reflections were made by our ancestors. And then the question was starting of life. There is no word in Genesis on bacteria, on single cellular organisms. They couldn't know about. However, of course, they had no microscopes, so they reflected, should we start with myself, with animals or with plants, and they felt plants must be first because then the animals have something to eat, and when finally, in the last day, human beings are created, we also have something to eat. So I find this Genesis an absolutely fantastic old story of how in these 10,000 years and up to 5,000 years ago, people reflected on how it came about, what they appreciate, and for their life. And of course, it is also consistent with beliefs. Part of these beliefs are religiously founded, part of these beliefs are just other kind of beliefs, how it is. Now, beliefs, together with scientific knowledge, is giving our worldview. And the worldview is, I find, for our orientational knowledge, whenever we have to take some decision for what we should do, or we in Switzerland go often to the vote, we have to vote for this, yes or no, and we do it oft by reflection and being largely guided by orientational knowledge, composed of, the orientational knowledge is composed of early embryonic and post-embryonic kind of impulses, then education, in fact, were lifetime education, and this should be enriched by scientific knowledge. This is quite important. So you see, I think scientific knowledge acquired up here has a cultural value for our daily life and consequences. It has another cultural value, namely for getting facilities for our life, innovations. And these have to be amplified by applicational investigations, which also depend, of course, on these research strategies. In recent times, we have learned to get very much novel research strategies. Think on imagining, starting not only looking with our eyes, but with magnifying glasses, optical microscopes, electron microscopes, and so on and so forth. We have instruments nowadays to look single atoms, and all the colorations which are available. It's fantastic how we enrich our insight into the laws of nature by having developed methodology. And novel methodology, I count also nanoscience to that, is in fact gives always a burst of innovation on the basis, not immediately after one day, but after perhaps years, decades, and so on. So this is quite important. Now the question is, should the civil society, that means all of us, have something to say what we would like to have as innovation for shaping the future? Yes, it should be. And as a sole example, I put in the development which we consider in the application should be sustainable. Now, let me say a few words to sustainability. Most of us, if we talk on sustainability, reflect on sustainability, we think that we should preserve the possibilities for 1, 2, perhaps 3, 4 human generations, 200 years. But the astrophysicists tell us that the sun is ready to give us still energy to the planet Earth for much longer time, in the order of I avoid to use the word billion because we here in Europe say milliards, so I rather say perhaps 3,000 to 4,000 million years. And that's a long time. I cannot ask you and us to consider sustainability, what we do nowadays, for that long period of time. And I'm not sure what kind of disasters will happen during that time. But I think we should think, ideally, it would be for the next million years. Our ancestors started agriculture, which is an impact, an important innovation for shaping the future. It started agriculture at that time, 10,000 years ago. So for me, I think if I reflect on sustainability of any development, we should have an horizon of at least 10,000 years. That's very hard to know. And we should, of course, getting scientific help for technology assessment each time. I do know that technology assessment is being done for nanosciences, nano applications, and the policy assessment also based on scientific knowledge should be done for political decisions. In my country, Switzerland, we every few years go to vote for or against using genetically modified crops for our daily food. And right now we have a moratorium. And in a few years we will vote again. And as long as a majority of the people think that this is dangerous, they will say no. And this is the impact here by the civil society. Similarly, nanosciences, in particular nanotechnology, they are afraid about that because it's another technology comparable to genetic engineering, and you will reflect, you will see you have many opposition against using nano things. I think this is completely wrong. I just tell you from my personal experience that there are so far no really indications whatsoever scientifically based that genetic engineering using genetically modified crops for our food is any danger as such, as a method. It could be dangerous in a particular case. So for the regulation, I propose one should have case-by-case studies before one uses an application, and when there is good safety indicated, one could go ahead. So with this scheme, I think this is of general value, as I said, and it's important to reflect how complex that study is. We study complex matters in nature, and important results from basic research are, in fact, having insights into laws of nature. And as long as we follow laws of nature, I think there is no particular danger for the methodology. And I am aware that nanotechnology is based on laws of nature. Nature uses nano interactions all the time for building up life, to carry out life. And I invite you to investigate and make lists of what laws of nanosciences for the enrichment of natural complexity is used every day, everywhere. Thank you for your attention.
So I think that the societal element in this drawing is so important, and I think it will serve in the discussion that we shall have afterwards very much. I don't know, does anyone want to ask already now a question to it? Yes, please.
I really appreciate the fact that you have gone through this again, because I think it's quite good. The one question I have, and this is something I have been thinking about since I saw this before, is you're using the term innovation and innovation to me is a constant state of improvement on already what is existing, as opposed to generation of something that does not exist yet. And I was just curious of how you make the distinction, and I want to make sure it's a philosophical distinction as opposed to just a language distinction on my part.
Yeah, it's a language distinction. I understand your point. In fact, sometimes it is really something absolutely novel. Think, for example, in another field. When the railroad was introduced, it hadn't existed before. That very much facilitates our life to communicate from one to another side. But the railroad, since ever it exists, it has steadily been improved, also by innovative steps. I agree with you.
Yes, Donald.
Just to say that you can always frame an innovation as being something like something we already had. So if you have a railway line, well, it's a little bit like having a road, only we now put iron rails. So anything in principle can be seen as a bit of a development of something else. Maybe flying is different, but it depends how you choose to frame it. But I think the point is generally taken. That, some things seem to us to be especially innovative, that we think, hey, I've never seen that before. And other things seem, well, that's kind of like. But there is a philosophical discussion about what is genuinely new.
Okay, well, yes.
So I think we